We've learned how to multiply polynomials. We've learned how to divide polynomials. Now we're going to learn how to factor polynomials. We have what's called the greatest common factor, also known as GCF. And what the GCF is, what is it that I can divide both of those numbers by and not get a fraction? I'm going to show you a long technique, and then I'll show you how to make it go a little faster. If I start with 20n to the 5th and 4r squared, if I were to make my factor tree, 20 is the same as 2 times 10. 10 is the same as 2 times 5. And both of these are prime. 20 is the same as 2 times 2 times 5. And then how many n's do I have? I have 5 n's. That's this factored as much as possible. I'm not going to do a factor tree because 4 is obviously just 2 times 2. And then I get r times r. I'm going backwards. I factored. Now I want to find what they have in common. Well, they both have a 2. Oh, they both have 2 2s. They both don't have a 5. The top one only has n's. The bottom one only has r's. My greatest common factor is 2 times 2, which is 4. Which means that I can divide both of them by 4 and not get a fraction. And that's the biggest number that I can divide them both by. That's why it's called the greatest. 2 is a common factor. It's just not the greatest common factor. Now that's the long way. Sometimes the long way is helpful. Short way. When I look at these both, I can see that we have an n to the 5th and we have an r squared. They have nothing in common. We just let those go. Now we have a 20 and a 4. Well, the biggest thing that I could divide into 4 is 4. And if I look at my 20, can I divide 20 by 4? Yes. If I make it 8, well, then I have a fraction. The biggest I can make it is 4. Okay, well, I can divide that by 4, and it works. And I can divide that by 4, and it works. 4 is my greatest common factor. I have 15 q to the 3rd, 30 q to the 10th, 10 q squared. Now, I'm going to do it without a factor tree just because I can do it a little faster without a factor tree. 15, I know is 3 times 5. And q, 3 cubed, is 3 q's. 30, I know is 2 times 15. 15 is 3 times 5. And I'm going to have 10 q's. This is why this is not the most efficient. You could always do this, and this is 10, which is 2 times 5. And I have 2 q's. Well, they don't all have a 2, and they don't all have a 3, do they? Oh. But they do all have a 5. They all have 1 q, 2 q's. 5 q q equals 5 q squared, which equals my greatest common factor. Now, let's look at it again, okay? I'm going to see if I can show you how to speed up the process a little. Usually, the letters are easier than the numbers. The most q's that I can get out of each one is really the same as the smallest number of q's. I can't get 3 out of 2 or 10 out of 2, but I can get 2 out of everything. I know q squared is the letter part of my GCF. We know that as far as the q's are concerned, I can only take 2. Otherwise, I'm going to run out on the last one. And I know that they're all divisible by 5, 15, 30, and 10. I have a 5 here. That would leave this with a 3. That would leave this with a 6. And that would leave this with a 2. We can see that there's nothing in common between all 3 of those. This is my GCF. I'm going to not do the long way anymore. Let's do the letters first. What's the largest number of S's I can take out of both of them?
S to the 6th power.
Good. Largest number of T's?
Just 1.
Correct. How about V's?
3. V to the 3rd power.
No, the other one doesn't have any V's. So
Okay,
not,
but just that, yeah.
that's it. I can't take 3 V's out of something that has no V's. I know 25 is 5 times 5. And I know 40 is 5 times 8. I definitely have a 5 in common. But 5 and 8 have nothing in common because that took care of this 5. 5 and 8 have nothing in common. This is my final answer. This is my GCF.